Next learning objective we're going to look at are present and future value of annuities. Again, same amount each year or same amount each month. Annuities, series of constant cash flows that occur at the end of each period. Car loan, a home mortgage payment, a college loan payment, same amount each and every month, same amount each and every year. So if you have that annuity, same amount, you can use these annuity present value and future value equations. First, the present value of an annuity is C times 1 minus 1 over 1 plus R to the T, all of that over R. Again, what is this used for? This is the mortgage equation, the car loan equation, the student loan equation, the credit card equation. And with this formula, you can find the constant cash payment amount, C, by filling in the other variables. If you've determined you can afford to pay $632 a month toward a new sports car, you call up your bank. The going rate is 1% per month for 48 months, about 12% per year, depending on compounding. It'll be higher than that if it's compounded monthly, daily, or quarterly. Can you afford to buy that spicy new Porsche 911 GT2? So you do your math, pull out the present value annuity formula, trying to solve for the present value. How much money can I afford to borrow today at the bank if I can afford a payment of $632 and the interest rate is 1% per month? Boy, I can only afford, because of the high interest rate, I can only afford $24,000. Looks like the Porsche is out of the discussion. Even though originally it looked like a high payment amount, and it is, we can only afford $24,000 loan if the interest rates are that high. Maybe a Scion, so we can change our lower expectation and buy a Scion and still be a happy driver. Spring break, good example here. Present value annuity. This is in terms of your credit card. You're having fun on spring break at Senior Frogs, and you need to put an extra $1,000 on your credit card. Can you afford to make? You can only afford to make that payment of $20 a month once you arrive back at college. Interest rate on that credit card is 1.5% per month, or about 18% per year, depending on the compounding rate. How long will you need to pay off that $1,000 of fun you just had? Again, use the present value annuity formula because you're only going to make a $20 payment each and every month, same amount each month. How long will it take you to pay off this $1,000 loan? PVA is $1,000. C is $20. That's a constant payment amount. The rate is 0.015, and the T is what you're solving for, how long to pay this thing off. If you do the math, 93 months, 7 3/4 years to pay off that credit card. That takes seemingly forever if you can only afford $20. So be careful with your spend on that fun spring break trip. Future value annuity. Again, we can play Who Wants to Be a Millionaire, and hopefully now I can afford to make smaller annual payments, same amount each year, and still get to my $1 million. And that's what we're going to try to do. Here's another example, $2,000 every year into a retirement account, paying 8% if you retire in 30 years. How much will you have in 30 years? So here we're going out to the future, out to the right, to time T. In this case, T is 30. And so 2,000 is your constant cash amount. Rate is 8%, 0.08. Time is 30. And I get a future value of this annuity of $226,000. So not just 30 years times 2,000 years, $60,000, but since it's compounding and it's compounding and compounding on interest, we're going to see a total at the end of 30 years of $226,566. Here we can play Who Wants to Be a Millionaire. Again, this time we want to see, can we invest a smaller amount each and every year? And how much is that amount to get to that $1 million? Again, you're going to retire at age 65. You're currently 21. And how much must you invest each and every year in the same amount in an annuity? So again, this is a future value annuity problem. How much must you invest each and every year in a small amount, same amount each year, to get to that $1 million? You're 21. You want to retire at age 65. So this is similar to the example we tried in Chapter 5, but that was one big lump sum. Here we're going to hopefully be able to invest a smaller amount each year and figure out how much that C amount is each and every year if I want to get to $1 million in the future. And again, we're going to pretend we can gain 10% on our interest on our money. $1 million is the future value. C is X. We're trying to figure that out. R is 0.1. T is 44 years between age 21 and 65. And if you do the math, you find using the future value annuity formula that you need to invest $1,532.24 each and every year, same amount each year for 44 years versus Chapter 5, which was lump sum time value of money, one big lump sum of $15,091 will also get you there if you're fortunate enough to have that money in the bank and can invest it. Annuity Due is used by some of our rental agencies downtown, some of our apartment owners, and this is the same amount you pay when the cash flows come at the beginning of the month. So you usually pay your rent on the first of the month, January 1st, February 1st, March 1st, and so on. And what does that mean? That means the realtor or the owner of the building can invest that money for an additional time period. So you just simply, to go from annuity due to a regular annuity, just multiply your answer by 1 plus R because they get to invest it for one more period. So they're very smart in finance in the real estate business.